functions, domain, and range. A function is a relation that's set up in a way that each element of the domain corresponds to exactly one element in the range. The domain is the set of all the meaningful inputs of x. Okay. So any number that can be plugged into your function for x is an element of the domain of your function. The range is the set of all the elements that come out as the output y. That's the range of the function. So each x can be paired up with only one y. Sometimes the y is written in what we call function notation, and it looks like this. Looks like f in parentheses with an x. That is read f of x, where f is actually the name of the function, and the x is the input variable. Now, we're going to determine if these examples are functions. To determine that, we want to make sure each of the x coordinates pairs up with exactly one y coordinate. So if we look here at f of x, this first example, I have the ordered pair 3, 5, -3, 6, and 9, 5. If I look at these, each x from here to here to here, those are my x's, are all different. So that means each number in the domain only has one y that goes with it. So we would say, yes, this is a function. If we look at this second example, it is also a function because each x is different. Now, if I wanted to change that to make an example that is not a function, let's take a look at the example where I have ordered pairs 3, 2, 3, 5, and 4, 7. Here, because I have two different points that have the same x coordinate, this example is not a function. Sometimes functions are written as ordered pairs. Sometimes they're written using the function notation. Here what we have is f, then the 1 in parentheses equals 2. That means f of 1 equals 2. That's the ordered pair, where x is 1 and the y is 2. f of 2 equals 3. So that means the ordered pair 2, 3 is in this function. And then f of 3 is 4. So that means the ordered pair 3, 4 is part of this function. So if I want to write f as a set of ordered pairs, I use the little curvy brackets to indicate that I'm talking about a set. And then I list the ordered pairs and I separate them with commas. Oops, I don't need a comma at the end there. If I want to write out what the domain and range are, the domain is going to be everything that I have for x. So my domain includes a 1, a 2, and a 3. Because your domain, let me change color here for a second. My domain are all the x coordinates. Now, my range is the set of all of my y coordinates. So my y's would be 2, 3, 4. Two, 3, and 4 make up the range. Now, here's another representation, how you can write a function. In this first example, the blue circle, the blue oval, indicates that these are elements in the domain. The domain is 5, 10, 15, and 20. The pink oval is the range because it's got the R above it. It contains the elements 1, 2, 3, and 4. The blue arrows show what is paired together. So this means I have the ordered pair 5, 1. I have the ordered pair 10, 2. I have the ordered pair 15, 3. And I have the ordered pair 24. This is a function because each element over here only goes to one element in the range. If I look at this example at the bottom, I see this one is not a function. Because if I list my ordered pairs here, I have the ordered pair 1, 3. I have the ordered pair 2, 5. But I also have the ordered pair 2, 6. And I can't have that 2 being paired up with two different y values. Here my function is written with the formula. Instead of listing ordered pairs, it's the formula. F of x equals 5x squared minus 2x plus 4. This is a polynomial function. Find the domain here means, again, find everything you can use for x. When we deal with the equations and the formulas that are written in this notation, you have to kind of ask yourself, is there anything that I cannot plug into this? Any number that I cannot put in for x? And in this case, I can put in positive numbers, I can put in negative numbers, I can put fractions, decimals, anything. So our domain, anytime we're dealing with a polynomial function like this, is going to be all real numbers. So that means it could be anything, from negative infinity all the way up to positive infinity. Here I'm asked to find a function value, f of -1. So that means I want to plug my -1 in for x. So the -1 is going to go in everywhere I see an x, which is going to give me 5 times -1 squared minus 2 times -1 plus 4. You've got to be careful with your order of operations here. -1 times -1 is +1. So we have 5 times 1 minus 2 times -1 plus 4. So I have 5 plus 2 plus 4 gives me 11. So f of -1 is 11. That means the ordered pair, -1, 11, is on that graph. Now I can do that. Also, I can put that function into my calculator in my y equals screen. 5x squared. In the y equals screen, you always use this button right here for your x. Minus 2x plus 4. If I go to my table, which is second graph, see table written above the word graph, I can use my up and down arrows to find the x of -1, because that's the number I plugged in. And it will calculate the y for that. So I can check my work here. I see that I've really did that correctly. I got a y of 11. I also can look at my graph. Typically, a good way to start looking at your graph is with a standard window. Zoom 6 will give you a standard window that goes 10 units in each direction. The graph doesn't tell you a whole lot here, but you can see that it's a parabola that goes up. Now, if I were asked to find the range on this function, seeing what I see on this calculator screen, the range, remember, refers to the y values. And I don't have any part of that graph that's showing up below this y value right here, which looks like it's a y value of 4. So that means if I were asked to find my range is going to be all of my y values that are bigger than or equal to 4. So my y would have to be greater than or equal to 4 to be an element of the range.